Hi everyone. Okay, we're going to have a series of videos for graphing rational functions. And the first video, all I want to do is talk about the guidelines for doing that. So just get those written down for your first video, and then we'll do 3 examples and probably do 1 example per video. So this lesson is going to have 4 videos, and we'll keep them fairly short, I hope. All right. Remember, a rational function is a polynomial over a polynomial. You got your numerator polynomial over your denominator polynomial. So the first thing you'll want to do is find the domain of f of x. And to do that, you want to set the denominator of x equal to 0 and just solve for x. That says what it cannot be. That says what x cannot be, and then that's easier to find out what x can be just because we know what x cannot be. Now after you do that, you have factored the denominator, most likely. Factor the numerator as well. If there's something that cancels, we want the simplified version of f of x. I'll probably deal with that in the 3rd example. Now, third, if f of x was simplified, we have to work on identifying wholes. Okay? Some of the x values from the denominator would be cause wholes. Some of them we'll call vertical asymptotes. I will worry more about that as we get the examples that deal with that. Now, number 4, find the y-intercept. The y-intercept is f of 0. Put 0 in for x and figure out your answer, and you're going to get your y-intercept. Number 5, we look for the vertical asymptotes. And that's from the simplified function. If you were able to factor both and cross out a common factor, that's the function I want you to use. Set your denominator equal to 0, solve for x. Those x values are your vertical asymptotes. Now, number 6, to find the zeros, set the numerator equal to 0. Again, from the simplified function. Set the numerator equal to 0, solve that for x. Now, number 7, find the horizontal asymptotes. Remember, n equals m. We had a way of getting that. If the degree of the numerator and the degree of the denominator are the same, the lead coefficient over lead coefficient, denominator or numerator over denominator would be your horizontal asymptote. If n is greater than them, there is no horizontal asymptote. If n is less than m, the x-axis is the horizontal asymptote. Y equals 0. All right, number 8. Now this might seem complicated, but it's not that bad. We just need to get a general idea of where some of the points are. You draw your axes. I want you to mark your vertical asymptotes, if any. Mark your zeros. I'm going to call those the critical values. Go ahead and put your y-intercept on the y-axis. Then this right here, find the y values for the x's that are between these critical values. And then you'll have some of these points for between the critical values, and that'll help you do number 9. Make smooth curves between the vertical asymptotes. Okay, I'm going to go to the first example on the next video.